So exponent rules of variables. So the first thing that we're going to look at is we are going to put on here product of powers. And then underneath that, we're going to do like the rule. So the rule for this one is where we have two things. So a to the n times a to the n. So they're getting multiplied together. They have the same base, but different exponents. And how do I, when I multiply two things with the same base, what do I do with their exponents? Add them. So it'll be a to the m plus n. And so we put the rule and that there. Then to the other side, we're going to put examples. Okay. So an example, a really easy example we can see of that is if we just have something like x squared times x to the third. So I want y'all to take a second and write out what you think that solution would be. What's the solution? X to the fifth. Because we say 2 plus 3, which gives us 5. All right. What if we do a to the fourth times a? What was that face for, Kingston? I'm just not used to seeing that sassy of faces coming from you. Colin, have you wrote a single thing down?
Yeah, I wrote it all down.
Oh, okay, good. What would be the answer to this one? What is the understood power on that A? There is an understood 1 right there. I'm actually going to switch that color even more. There is an understood 1 right there. So what do I need to add together? 4 plus 1. And that'll actually give us A to the what? 5th. Okay. Now we're going to look at 2a to the second times 4a to the fourth. Is there exponents on the 2 and the 4? I mean, they have the understood ones, but they're not the same base or anything like that, right? So what do I do with the 2 and the 4? I just multiply them. What is 2 times 4? And then it'll be a to the 6th. All right, now we're going to start looking when we have, let's try a squared b to the third times a b to the fifth. Again, what's that understood power on that second a? So use that. And now when we multiply these, I need to combine my exponents on the ones that are the same, right? The same bases. So I can do a and a, which will give us a to the third power. Because 2 plus 1 is 3. And then we also need to use our b. And it'll be b to the 8th power. All right. For this one, is there anything I need to multiply that constant by? Is there anything to change it? So I just need to put my 2 there. And then it'll be a to the what? 3. B to the, what was that? It is the 5th. All right, and we are done with our examples for product of powers. And now below that, we're going to do power of a power. And as we do power of a power, okay, we are also going to look at power of a product. Just because these are very, very similar. So all this is when we have a to the m raised to the nth power. When I raise a power to a power, what operation do I do with the exponents? Multiplication. So that'll be a to the m times n. Okay, and then we're going to take that a step further just by looking at what happens if we have a to the l, b to the m, and all of that raised to the power of n. Okay, there's a reason I wanted to do it this way. Okay, is because whenever we have something in there that's got multiple pieces to it, essentially what we're doing is we're going to take that and we're going to apply it to both of the pieces. So it would be like a to the l times n, and then b to the m n. So we're just multiplying the powers of both of them, okay? Now, for our examples, let's start with just a basic one. Let's do a to the 5th to the 3rd power. If I raise a power to a power, I need to. So it'll be a to the 15th. All right, now let's do 2x squared. Where are you going? Oh, you checking out?
Yeah. My friend Kylie told me that she's gonna look more, but she just goes up to like the same signs and stuff like that.
O to be 18.
Should I be there? 5:30.
I'm just going to stay here after school.
Okay. That's good.
She's checking out.
Yeah.
She was telling me to be here for wrestling senior night.
Well, you're 18, you can just leave.
You have to check out.
Yeah.
He's too heavy. Like, you don't have to call his parents though, right?
I'll see you later.
I don't know. Apparently not. I know. He was like, wake up. What? You can just leave?
Well, it's weird. It's like if your parent writes you an early dismissal form, they give you a little blue slip, and if you shut it down, you can just leave. And if you go to the nurse, like you call
But then-
your mom, and
But then when you get 18, it's a little bit different.
yeah,
It's weird. I don't know.
I'm 18.
No, you ain't.
I gotta check
some people leave after 6 periods for work related.
That's co-op though. That's different. That's something entirely different. There's lots of ways you can leave once you're a junior and a senior.
So should I go like the Bryant Center or something?
Bryant Center's different than co-op.
Early in the morning.
Or you can do an afternoon Bryant Center.
I've never seen that.
There is.
That's all.
Anyway, we have gotten off topic. So for this one right here. Okay. So do y'all see how this 2 is inside that parentheses? That means that 2 is getting squared too. So what is 2 squared? And then what is x squared? Exactly. So, I want us to talk about this. You don't have to write this on your paper. I'm just doing it so it'll, but, so if we have 2x squared, like do not write this, okay? But if we have 2x squared, right? What is being squared there? Just the x. This 2 is not being squared. We don't need to do anything to it. But if I have 2x squared, that is when we will see that this has to square the 2 and it has to square the x, okay? I just want us to remember that. All right, now we are good to look at another example. Let's do I don't want to do that. All right, do a to the 5th power times b to the 4th power, all to the 5th power. It was, but I quickly changed it after that. I didn't want to do another 3. So it's going to be a to the b to the perfect. All right, now let's do one more, and then we'll call it for this one.
Go wash my hand off.
What did you?
My finger got caught on disc somehow. Also, where are
And
the
you're bleeding?
I guess it really hurts.
I don't have any Band-Aids. Go to the nurse.
Okay.
There's a scrub pass back there. Grab it with your non-bloody hand, please.
Okay. What?
Yeah, I'm out of Band-Aids, so I want to send you to the nurse to get a Band-Aid. And that probably needs some antiseptic on it. Make sure you tell them you cut it on the desk because it definitely needs antiseptic. Those desks aren't washed nearly enough. All right, so we have 3x to the 4th, y to the 2nd, to the 7th power. That is going to be a big number, yeah. What is 3 to the 7th power? No, it's not 21. 3 times 7 is 21, but 3 to the 7th power is... That's a calculator question. I don't even know what the answer to that is. I'm making this up as I go, and I still don't know the... It's not that big, dude.
How was y'all bet?
What is it, DeVale? And then it'll be x to the y to the... Perfect. There we go.
I thought we were doing the A25, B25.
Okay, but does us doing it with some variables help kind of get the idea of what's going on a little bit better? All right, so the next one we're going to look at is we're going to go below that, and we are going to go to, we're going to skip negative exponents for right now. We're going to go back to that if we have room. We're going to also skip 0 exponents. What does it mean when you have an exponent that's 0? What's the answer? What is the answer when we go 5,886 to the 0 power? Negative 8,572 to the 0 power. Anything to the 0 power? Except? All right. Now, we are going to look at quotient of powers. I'm not going to lie to y'all. When I took the ACT back in the day, I had a question. That was a 0 power one, right? And I was like, oh, this is 1. This is 1. But then I was like at the last few minutes where like I was just looking back through my booklet real quick, and I sat there with my calculator and I kept putting it in to make sure it was 1. I put it in like 3 times because I kept thinking I did something wrong. I was like, there's no way. I'm just freaking out because it was like a big number, and I was like, no. So it's good to know because it will save you that hassle of panicking over a problem. Yeah, you're cooked. It's the test you take to get into college, and it's required in the state of Alabama for all high schoolers. You take it your junior year at the school. You already took the pre-ACT. You took the pre-ACT this year.
Wait, what's the best grade you can get in the ACT?
36.
What you need to get? What you need to get into like Harvard?
I don't know their ACT requirement.
What college you go to?
UAB. To go to UAB, you just had the minimum ACT they would accept is a 19.
How you going to UAB but you live in Mobile?
I moved. I didn't grow up in Birmingham either. I grew up in Northeast Alabama, and then I got into college at UAB. I went to UAB. Then I met
You not still in college?
I'm in my master's program, but I'm getting that through South.
Oh,
But
okay.
and then my husband got into medical school, so we moved from Birmingham
He must
to
be at
Mobile. He's at South. If he was at Oxford or Yale, I wouldn't be here. I would be with him.
Oxford.
That's in England.
No, it's not. There's Oxford, Michigan.
And there's Oxford, Mississippi too, but that's not the college. Oxford College is in England. Oxford, Mississippi is in Mississippi, and Oxford, Mississippi is actually where Ole Miss is, I think.
What's that? Why do?
All right, y'all, we're back to our topic. Casey got me all off topic over
I
here.
got y'all.
Between you and George, it's pretty easy to get me off topic. All right, quotient of powers.
I think the phone might be ringing.
You think?
Maybe the Kyler's
We're gonna keep
Let's not speak that into let's not speak that.
Let's not speak into existence. That's Casey's early dismissal.
Yes, ma'am. Casey Bartle, you have an early dismissal.
Casey.
Get your notes
I think he manifested that actually.
from someone else once I'm done with them.
Okay.
Yes. When Joey gets back.
I'm definitely easy.
All right. So quotient of powers. It is quotient of powers, not quotient of power. That feels like a evil villain. But in their their mission to get power, the quotient of power. I guess.
Check out.
Just go check out. All right. See Lloyd.
You're gonna hear me out of everybody who's talking. I wasn't even talking out loud.
See, you know I'm just picking on you, right?
No. Maybe. Yes.
I am, yes. It's just because you get so upset. You're like, oh.
Why do you have to check out?
Hmm?
Why do you have to check out? Why don't they check you out?
I don't know how it works, dude. I'm not a senior. I'm not a student here. I don't know. I went to a different school. I graduated 10 years ago. I don't know what they do anymore. I just work here. All right. Everyone. Shh. Tyler. Oh. I really thought you just walked in here flipping everyone off. With she wasn't flipping everyone off. She was holding up her ring finger because she hurt herself, and then she had to get a Band-Aid. Okay. Oh, no, I decided to record this lesson, and so it's a little chaotic, yeah. That's why I leaned over and said she wasn't holding up her middle finger. She was.
I wish I could give you antiseptic, and then you gave me an alcohol wipe. So now my finger's throbbing, and it really hurts.
I understand, but that is much better than infection from someone that wiped their snotty nose on the desk.
Stickers on the desk.
Yeah. It's better to take care of it now and get some alcohol on it, and then without Rishi, turn around. Colin, shh. Okay. It's on the other end of your pencil, sweetheart.
I lost it.
So we have a to the m divided by a to the n. When we divide, what operation do we need to do with our exponents? So we're going to get a to the m minus n. So let's look at a few of these. It's okay. So we're going to do a few examples. So let's do x squared or actually I don't want to do that. I want to do x to the 5th over x squared. So when I do this, I have to subtract from the numerator's exponent minus the denominator's exponent. Yes, ma'am.
Is that a plus?
Squared. That's a minus. Okay, and so when we get here, we would say x to the 5 minus 2, which is what? What is 5 minus 2? X to the 3rd. All right, now we're going to look at
That was
yes, when DeVille gets back. All right, so for this one, is there anything I can do with that 2 in the denominator? So do you know where that stays? On the bottom. Is there anything I need to subtract from the a's exponent? So where's that going to stay? Then if I simplify b squared divided by b, what do I get? B to the 1, which is just b. And that 2 is going to stay there because nothing changed it, okay? Let's see what else we can do. That 2 is in front of it, multiplying against it. It doesn't come with it.
So what happened to the 2?
Over here, the 2 just stayed there because we didn't do anything to change the 2.
I'm talking about the exponent.
Okay, so we did 2 minus 1, which gave us the 1. Okay, for this one. Okay, so for the x's, it's like saying x to the 5 minus 2. And then for y, it would be y to the what? 1 minus negative 3. What is 5 minus 2? So x to the 3rd. And then what happens when you subtract a negative number? And so you get y to the and that's our answer for that one. All right, and then we have one more section that we're going to look at real quick. So let's see how much room we got. Is that about how much room y'all got? Oh, wow. Does anybody have way less? It's okay, Hayden. All right, now we're going to look at power of a quotient. And that's just where we have a fraction that is being raised to a power. And when we have a fraction that's being raised to a power, what we do is we raise the numerator and the denominator to that power. So it's like saying a to the m, b to the m. Then we're going to do an example. right, so for this one, because we are raising them to a power, we have to raise this one to the power, and we also have to raise this to the power. So when we raise the numerator to the correct power, what's going to be x to the what? 10. When we raise the denominator to the correct power, it's going to be y to the 5th. And that would be our answer. All right, let's do all of that. So we have to raise everything in the numerator to the power of 3. So that means we're going to have to raise the 3 and the exponent. We have to raise the 4 and the 5. Does that make sense? We got to do everything. So in the numerator, what is 3 to the 3rd power? What is a to the 2nd to the 3rd power? A to the 6th. What is 4 to the 3rd power? 64. And then b to the 3rd power is what? 15. And that's how we would do that. Hold up. I got an email today that told me I have to teach bell to bell. And we certainly know that I don't start at the first. It takes me a couple minutes to get started. But yeah. So we are going to stop writing here, okay? But I want y'all to pay attention while I do this real quick. So don't be moving around very much, okay? I want to go over this real quick. This is negative exponents. So if I have a whole fraction to the power of negative 2, anytime that I have a whole fraction that's got a negative exponent, what happens to it? What does that whole fraction do? It's going to flip. And so we'll flip that around, and then our exponent will become positive. Okay? But instead of it looking like that, what if it looked like this? Which part is the part that's got the negative exponent? A. So where does A need to go to? The bottom. So that would flip to 1 over A squared B. What if it happens the other way? So we get B to the negative 2 under A. What do I need to move my B to? The top. So that would be A B squared. Okay, if you can do that part right there for negative exponents, and remember if you have A to the negative 2, that's just going to be 1 over A squared. You will be A-okay with negative exponents. Okay, I just noticed that the biggest things we were having issues with were the ones where we were doing multiple operations in the same problem. That was getting us a little Cocoa for Cocoa Puffs.